Good morning, everyone. Thank you so much for taking out time to attend today's session. And we see more people joining in. So just give us a moment, and we should just wait for others to join, and we will just get started. So thank you for your patience.
So good morning, everyone. As we start in a while, kindly request you to take a moment to review our safe harbor statement regarding the information we are about to share with you. So please note that this information is confidential and doesn't constitute a formal notification. You will receive a formal notification with program guide and other documentation if required. So of course, what we are going to share is all there in the product, but there might be some forward-looking capabilities also that are shared in today's presentation. So please be mindful of that as well. So Avinash, I think we can get started. And as we get started, perhaps it's good to know who's on the call. So can we please run our poll, please? Yes, thank you so much. And dear audience, as we are going to present a solution that will be touching a couple of your workflows and the areas where you contribute in your work. Just wanted to know whether you fit in one of these areas. So, are you a designer? Are you a mechanical designer? Or are you an electronics designer? Is your field related to CAE? Are you perhaps in control of the complete design to manufacturing process? Or is it something else that you do? Perhaps this is something that we would request you to kindly poll. This will help us understand as in who is there, who is perhaps since I cannot see you, we are not interacting, so it's good to know who is listening to me, who is perhaps attending today's presentation. So we'll keep it for a while, a minute or so more, and request you to please give your poll, please select a suitable option. If you are not any one of those that is listed on the in the first four, maybe you can click others. That's also absolutely fine. So a designer, maybe what we are looking at perhaps is someone who is doing the mechanical design or the complete product design. It could be absolutely anything. If it is specific to electronics, if you're doing something with respect to electronics, please click on the electronic designer. If you are doing simulation, that is computer aided engineering, CAE, analysis, FEA, any of those, then please select the CAE specialist. And if you are responsible for the complete design to manufacturing process in your organization, please do select the fourth option, that is design and manufacturing team lead. And if you think that none of these four options perhaps are something that you fall under, please select others. So maybe half a minute more for the poll. Yes, people are voting. I believe there are some people who still need to vote. Kindly requesting you to vote. Some more people left to vote. It doesn't matter if you're not too sure. If you are contributing to design in any way, you may just click designer. Or if your role entails design plus simulation and simulation heavy, you might want to do CAE specialist. Yeah, I understand that there are many people who might be doing both design and CAE. That's absolutely fine. You may just click on the designer. And if there are people who are perhaps related to electronics, please click on electronics as well. Fine, so I think we will get started. Maybe if you are done with the poll, we are going to close the poll now. Thank you so much. And here you go again. This is my screen, and welcome to today's session. And thank you for the opportunity to be presenting in front of you and to you all. And what if I told you I could give you the agility and connectivity to meet growing demands and spend more time innovating rather than iterating to better your business and shape a thriving future? My name is Sanjeev Ghosh, and I am a senior technical specialist with design and manufacturing at Autodesk. You can also follow me at my Twitter handle, which is at the rate 2D3DND. So in today's world, we are talking of business risk and volatility and increasing costs. These are all threats we face every day, and the need for productivity anywhere is only increasing. Unfortunately, the product development process today looks like this. A full 30% of an engineer's time is wasted on tedious tasks like chasing down the right version of a file. It's messy and it's complicated. It's slow and painful. And it's limiting your ability to make the changes you need to make in order to survive. Imagine what you could do with a solution that can flex to your needs. Fusion 360's flexible and intuitive platform can be configured to your team's size, use case, and workflow. So you get access to the enterprise grade features and services you need and only pay for what you use. A solution that can intelligently power your decision making. So Fusion 360's generative design identifies thousands of solutions to the problem you define, simulates their performance, and optimizes for your constraints and manufacturing capabilities. So you can get to more high performing, cost effective, and sustainable designs that you couldn't have reached on your own faster. Solution that can help you move your business and industry forward. Fusion 360 invests in the future of product development and manufacturing, catalyzing innovation across disciplines. So your team has the tools to automate mundane tasks, the agility and connectivity to manage supply networks, and access to the latest manufacturing technology to realize previously impossible outcomes. Fusion 360 can connect your entire product development process at every phase on a single integrated platform, right from product definition to engineering to production engineering and shop floor production as well. So it's one solution that takes you through the entire journey of design to manufacturing. And not just that, and we realized that you would have made investments in various other solutions as well, and I'm sure you are using some of the solutions that are highlighted here. So Fusion 360 is a open platform that is intended to be that can be used with any other file format seamlessly. So this is the advantage. It will not put a stop to your existing flow. It will rather complement and give you additional productivity gains. Now let's look at the workflow for industrial designer. Fusion 360 improves workflows between design and engineering groups by offering a variety of modeling methods to meet each team member's needs. With stakeholders working on one unified CAD model, everyone shares information and ideas in real time, increasing efficiency, throughput throughout the project. So work in both 2D and 3D in one easy to use CAD system supporting essential design methods with tools such as subdivisional, history based, direct, and mesh modeling tools. Design intent is maintained no matter what stage of development you are in. So it consists of a comprehensive set of tools, giving you the ability to think out of the box. The conventional parametric design methods, which we have followed, and we definitely gain a lot of benefit out of following rules in a parametric design environment. But sometimes when at the initial stage or conceptual stage, we don't want to be sort of governed by rules and parameters, wherein the tools such as the freeform design environment with subdivisional modeling techniques comes handy. Also tools for elaborate sheet metal design for creating your enclosures or other sheet metal components. Direct modeling techniques where you really don't have to worry too much about the feature tree. You don't need to really figure out where the feature is sitting and what is the other feature that might get affected when you perhaps edit a feature that was created previously. Sometimes we face a lot of issues when we are editing a part which has a lot of features in the feature history tree. And this is what Fusion 360 helps you with the method of direct modeling. And also combination of all can result in a model that transcends across all these functions. So there could be a model that is part freeform, part parametric, part direct edited model as well. Not only this, we can also take a mesh model. Now this mesh model can come in from a laser scan, from your laser scanning device. So if you have a part for which you don't have design, or which you don't have a documented drawing or a design, you can simply scan it using your laser scanner, is using your scanner, and get that scan data in the form of a model that can be incorporated in your design as a mesh model. So many possibilities out there. So concept development with freeform modeling, it's a very interesting technique where you can simply use the subdivisional modeling capabilities to manipulate push-pull. With push-pull gestures. You can edit faces, edges, and points. You really don't have to worry about features, sketches, parameters, and dimensions. It's a simple, easy way to manipulate geometry to get to the desired shape. And sometimes the desired shape is not more of an engineering criterion. It's more towards the aesthetics. It's more towards the functional requirements with respect to its usage, which is not essentially and thoroughly defined by dimensional parameters. So this is where a free-form modeling environment helps, and that is what Fusion 360 offers by way of subdivisional modeling. Now, in our product development process, we have collaborators, we have people who review our design, who need to get a feel of what we are building. And before giving a go ahead, there are a lot of stakeholders involved, including senior management, who want to see what's being built, what are the alternatives that are being created, and how they will look in real life. And this is the time when you really might want to create very high fidelity photorealistic images. Now in Fusion 360, we of course have the ability to create photorealistic images and very nice videos, but so do many other software. So so it's absolutely something that a lot of solutions offer today. But the advantage that Fusion 360 offers is that in conventional tools of today, when you are trying to do rendering on your desktop, you are perhaps using up a lot of resources, and when this process of rendering is in is taking place, you will perhaps not be able to use a lot of other applications, and it really blocks your machine from letting you do anything else. So photorealistic images, creating them might take up a lot of valuable resources from you, and take up and sort of waste your time, rather, I would say, by not letting you do something else when this process is going on. So Fusion 360 allows you to do the same with a cloud environment. So the difference here is that you can apply materials, apply textures, apply colors, apply visual styles in your desktop interface, but you leave the calculation of the realistic image to the cloud, where the cloud helps you in computing and giving you the feedback in the background. So you can absolutely do something else in this time, and even shut down your machine as this process is happening, and you will be notified when your image is ready. So very interesting way, saves up a lot of time and energy and resources, and leaves you with the resources to do your productive work. Now, sometimes, as I said in the initial, when conceptual design stage is going on, perhaps you want a lot of freedom in manipulating the shape of a model. But when it comes to the specifics and you want to build into the engineering intent of the design, you perhaps are more concerned with the exact dimensions of features, things that are on the other side. For example, if you are designing a plastic component, the outside perhaps was designed with the subdivisional modeling techniques in Fusion 360, but on the other side you have strengthening features, holding features, features for keeping it together with other parts like bosses and parts where you're going to fix screws and parts where it is going to get assembled with other components in the assembly. So these are areas which definitely need to be dimension specific. So we also can define our surfaces by specifying dimensions to be more precise in our modeling. So we can combine we can go on from the freeform modeling technique to parametric surfacing seamlessly. So, at the initial stage when you are perhaps defining and designing the shape and form and the fit, the form, fit, and the function of your design, and sometimes it might be necessary to get a feel by looking at it on the screen. And if you are designing something that is perhaps to be interacted with, you might really want to get a feel of that interaction, which might not be really possible with the 3D design. And what Fusion 360 also offers you, or rather allows you to do, is by integrating a 3D printing workflow, you can directly take it to the 3D printing environment and get a part quickly printed without having to move out of this single environment. You can jump from your conceptual design stage to 3D printing or CAM and get a prototype made very quickly with all the tools of slicing and uh, both plastic as well as metal printing capabilities, all within Fusion 360 supported. Now let's look at the mechanical engineer. So pushing the limit with 3D modeling. So we definitely try our hand with 3D modeling and try various approaches to 3D modeling, and perhaps a lot of tools out there allow you to create the 3D model that you're looking for. But sometimes we are too dictated by our existing workflows, and we exactly try to model or replicate the way the design is supposed to be in the conventional sense and with our previous knowledge. So we have that design in our mind and we just try to replicate that design in 3D. So it's just a translation of what we know the design should be, and that is what we try to create, and try to use all the best practices and the tools that are there in the 3D modeling software to create. So what Fusion 360 allows you in this scenario is it allows your products with a complete set of 3D modeling tools that includes parametric, freeform, direct, and surface modeling, a combination of all the tools put together. And engineer products with a comprehensive set of modeling tools to ensure form, fit, and function of your products with various analysis methods as well. And not just that, it also helps a mechanical engineer to solve engineering challenges faster, simultaneously generating multiple options of your design while consolidating parts, reducing weight, improving overall performance. And what this actually allows you to do it, sometimes we are perhaps we don't get into the stage of detailed simulation just for the want of the solution, as perhaps a proper solution that does our job might not fit the bill. So we here with Fusion 360 you can avoid overpriced simulation tools, test your designs to ensure that they will survive real world conditions using one model in the one affordable platform, that is Fusion 360. So as I said, from the conceptual designer's workspace, which could be a combination of freeform, parametric, uh, solid modeling, parametric, surface modeling, mesh modeling, and so on that we saw earlier. What goes on and what continues in the mechanical engineer's workspace are tools that are again very detailed and elaborate. And some of the familiar tools that you might already be knowing with the tools that you use today for solid modeling and detailing. Tools such as 2D and 3D sketching, creation of parts and assemblies, mechanisms, sheet metals, surface modeling, and drawing creation. So all these capabilities are definitely something that Fusion 360 offers. So maybe I'm already getting some questions in the chat window. What I'll try to do is, since I don't want to break the flow, I would rather try to answer some of your questions towards the end, and I hope this should be fine with you as well. Yeah, thank you. Direct and mesh editing. Now, where do we use mesh editing? Sometimes we have old parts that we want to digitize and incorporate those parts in our design, or we want to incorporate or create a design that interacts with an organic shape, such as in this small image towards the bottom right, we see a earbud being designed specifically for the ear of a particular person so that it fits in correctly. So how do you do that exactly? How do you get that exact shape? You can get that shape by capturing the shape of that ear by various ways, by things such as, of course, scanning is one of them, but there are newer tools that also support this workflow, such as using your mobile phone to perhaps capture a SD video and extracting 3D model out of that video is something that is also supported by an Autodesk technology known as Recap. So Recap stands for reality capture. Now you can get that design from Recap, which is a mesh file captured either using scanning, such as laser scanning, or photogrammetry using a camera. It could be your mobile camera, it could be a SLR, it could be a good camera. Of course, it has to be it should have perhaps a good amount of clarity and focus. So you can use these methods to capture organic shapes, which really do not form a part of your product, but where your product needs to interact, such as this example of an ear, or it could be a wearable that you're designing for the purpose of your hand, or a prosthetic, could be absolutely anything. All these can be done through tools like Autodesk Recap, and that information coming in from Recap in the form of a STL or a OBJ file or a mesh file, as we call it, can be incorporated in your design, where you can take references from that to extract the right shape into your design. Now, designing shape and form is fine. It's of course the starting point of any design. The definition of a form, the definition of the specific dimensions, and also incorporating workflows from mesh. That's all great because that allows us to complete our 3D model and document it properly. But finally, at one point in time, we also need to figure out if the model that we have created meets functional requirements. So many times it's in years past we definitely used to do this by way of physical prototyping, and that has definitely reduced over the years with the advent of new tools. It's just that it's a matter of accessibility of a lot of those tools that are out there. There are very good tools out there in the market, but are they all accessible to you? Can you immediately try out a prototype using some of those tools? Maybe you intend to do that, but the cost is prohibitive. Your budget doesn't entail involving services from an external party for simulation. and you want to perhaps do it many times in your design process. So is it really possible, or do you really need to spend on a software? If you have the budget, you definitely can do that. But what if we said that Fusion 360 allows you to do all this testing on a digital prototype right inside the window of Fusion 360, just by moving from your design workspace to your simulation workspace? That allows you and gives you access to uh, Autodesk Nastran on the cloud. So here we have a mechanical FEA or a mechanical simulation solution that allows you to analyze for various types of physics. It could be either static, nonlinear, which is stresses, which is perhaps the most basic analysis that we can do, or it can do modal frequencies, thermal and thermal stresses, and even things like buckling and event simulation. And the good part is that some of these solutions might take up a while when you're doing it locally. And similar to the problem that I explained in the rendering or the part of this presentation, the initial slides, where I was talking about visualization and creating a nice looking image, and the process of rendering taking up a lot of your physical resources, time. The same is applicable to FEA as well. And sometimes the process of FEA, if you're defining and you're in the final stage of the defining the problem, it might take a while to solve the problem with the resources that are there on your in your workstation or your laptop. The amount of RAM, the amount of CPU power that you have got may not be sufficient to complete it in the time that you're looking for. And sometimes it might run in a couple of hours. And this time is absolutely the time where you are not able to do anything else on your machine, and perhaps you just are waiting to complete the entire task. And the problem here might also be that as you are completing the task, as the system is analyzing, calculating all the results that based on the inputs that you have given, after the analysis is done, you might again come to the conclusion that your design needs to be modified, and then again you need to go through that cycle again. With Fusion 360, what we have done is we have provided the cloud solve, and you can definitely solve multiple iterations simultaneously on the cloud, and continue to work and progress on your design parallelly as the cloud solve goes on in the cloud. So it's really a great way of having to save your time and perhaps valuable resources at your hand, and continue to do the work that you intend to do. So a lot of things can be done parallelly and simultaneously, so that there is no waste of time, resulting in definitely much more productivity. And finally, any 3D design, however good it is, definitely has to be documented. There are processes we follow. There are people who interpret these documents for the purpose of manufacturing, for the purpose of ordering, and for various other means. So documentation is definitely something which is a part, and something that we cannot do without even today. So a 2D document gets filed, gets approved, gets circulated, and gets and it gets consumed across various stakeholders. So what we can also do through Fusion 360 is definitely we can create the 2D with all its details and connect it to the 3D model, which of course should be expected from any good design software. Now, this is something very interesting, and if you have seen other previous webinars, some of you might already have, and you would have also heard of the word generative design. Now, perhaps today I'm not going to show generative design, but I'm going to talk about things that you can perhaps do. And this one example here on the screen with this nice looking and interesting looking shape is not really a very big marvel of engineering, as in the shape definitely is, but the place where it is going to be used. Conventionally, if I go on to design it, it is perhaps a hub which is connecting four shafts in those four pieces. So, and perhaps it is some device that is allowing you to do that. and some connector. So in the conventional sense, if I were to design this as a mechanical engineer, perhaps I would form these as 4 different cylinders, 4 different parts, and perhaps weld them together, join them together in a certain way. So which means 4 different drawings, 4 different designs, 4 different parts being manufactured and being put together through a manufacturing process. What if we could find a way to combine these all together and also manufacture it through a conventional method, such as 2.5 axis milling, a simple 2.5 axis milling? So the solution that you're looking at that was thrown up by generative design when we define this problem here is a simple design. Of course, many alternatives were thrown here, as shown in the right hand side bottom corner, but the one that was chosen here is a very, very simple design that performs the same function of those 4 parts joined together through welding or through other means of joining, and available to you as a single part manufactured from a single piece of raw material, saving a lot of time, also ensuring that the weight of the overall part is less than the assembly that we would have designed. And definitely there are a lot of applications for this. One interesting application that we have also seen people starting to use generative design is for defining work holding fixtures for perhaps a CNC machine, or places where you need to hold a job on the surface of a table for a process. So sometimes we figure out and we really spend a lot of time in designing those fixtures, but with generative design you can simply specify areas of contact and areas to avoid, and perhaps the potential forces that are likely to act on the fixture, and tell generative design to derive the right shape that will suffice the need of fixturing. So custom work holding devices is another area where generative design is definitely finding a lot of use, and all this again happening on the cloud. Now, any design today is, any design we see around us, it's not a pure mechanical design anymore. It's a combination of electrical, electronic design as well. And in that scenario, we see a lot of people working together to complete a design. There is a set of electronic designers who are doing their bit of the work. They are collaborating with their counterparts from the mechanical design team, and they work on different disconnected tools and share information in generic formats, which also means that they are not in sync most of the times because of the changes that are happening in their respective workplaces. So what we are doing here is we are perhaps allowing a comprehensive end-to-end workflow in Fusion 360 powered by the Autodesk Eagle technology that was acquired some time back. It allows you to quickly capture your schematic through automated controls and wizards, along with access ready to use components and content libraries. It also allows you to build on the schematic by moving seamlessly from the schematic editor to something known as the PCB editor to build a working PCB board. And not just that, it is not just a documentation and 3D modeling tool, it also checks for the circuit performance through fully automated functional SPICE simulation for your schematic and simulating the thermal loading when combining the mechanical enclosure with the circuit to ensure that the design meets the design guidelines. And with your validated PCB design, you can also bring your design closer to reality by creating manufacturing data quickly and easily. So we also support the complete manufacturing process of a PCB. You can create standard Gerber data. Now, this word Gerber you may not be familiar with it as a mechanical engineer, perhaps, but someone who is used to manufacturing PCBs, designing PCBs, definitely familiar with that. It is that information that defines the various layers and the way the routing happens in a PCB circuit. All that information can be essentially it is the CNC data used in the PCB industry. You can pick and place and others in as little as 2 clicks using built-in templates for manufacturing. So all this right now in Fusion 360. So you can perhaps go on to define your PCB in context of your mechanical design, or you can define your mechanical design constraint to your PCB circuit. Both the workflows are possible. There are most of the instances where we perhaps keep mechanical design as the leading design and take that to refer and continue our electronic PCB shape of our PCB design. But sometimes the workflow can be the opposite, exactly the opposite also, where the shape of the PCB might drive the shape of your mechanical enclosure as well. So both the workflows are supported in Fusion 360. So some of the benefits and your capabilities: the schematic design interface allows you to create a schematic exactly the way we support schematic design of an electrical circuit in AutoCAD Electrical. Then we have PCB layout and routing tools, very similar to the 3D electrical harnessing capabilities or 3D routing capabilities in Autodesk Inventor. The same capabilities in Fusion 360 for routing your PCB, and integration with the PCB design itself, and the SPICE simulation I talked about earlier, supported by tools such as electronics cooling. So any electronic or electrical circuit generates heat as there is a lot of electricity flowing, and it is very important that you figure out how the air should flow over the circuit, where it should be evacuated from, how which is the most heated part of the circuit as it is working and doing its job. So all that can be simulated and validated using some nice CFD tools we have inside Fusion 360 for the electronics cooling. And finally, going on to the PCB manufacturing as well. The manufacturing engineer or the CAM programmer. So for them, we can directly go from design to manufacturing faster, quickly importing your designs with the largest set of CAD data translators for 50 plus different file types, directly edit existing features or model fixtures with a truly integrated CAD CAM platform, which means that of course you can design everything in Fusion 360, but if you are using Fusion 360 and you are that part of the team that is only doing the manufacturing or the CAM, you are not the one who is perhaps going to design the component, and you might be receiving designs from a different file format because your company has already invested in a different designing tool. So with Fusion 360, you can uh, accept 50 plus file formats and not only just take them as dumb geometry, but you can do quick editing to suit your manufacturing process, design fixtures for fixing the geometry on the bed to machine it. You can generate toolpaths in minutes and not hours. Effortlessly set up and programming allows you to make fast parts faster. You can post full NC programs with a post processor from extensive library of free, open source, and fully editable processors. From high efficiency roughing with adaptive clearing to simplified control of multi-access machines with tool orientation, Fusion 360 makes it easy to program your CNC machine fast, and you can manufacture with 2.5, 3, 4, and 5 axis milling, probing, turning, mill turning, and profiling operations. And this is all paired with a powerful post engine, all included alongside your professional design tools. So as I said, Fusion 360 CAM supports all kinds of workflows starting from 2 axis, 2.5 axis, 3, 4, and 5 axis milling toolpaths, positional and simultaneous as well, doing turning and mill turn, even supporting the 2D cutting processes such as water jet laser and plasma contouring. And not only subtractive. Now CAM is a word that perhaps was very synonymous with subtractive at one point of time. Now the same CAM is a wider term which talks about both subtractive and additive. Now, what I talked about on that in the first three sections was about removing material, but we also fully support the additive process, and being able to 3D print or manufacture additively is very well supported for both plastics and metal right inside Fusion 360. So it's just about getting from design to manufacturing as fast as possible, and being in the same environment. Changes to your design are easily translated back to your manufacturing environment also, without having to really redo the entire program from scratch. You simply have to update your program based on the changes that were propagated from the design. So it's being in the same environment has its advantages. It's connected to the design always, and changes happening to the design are update highlighted, and you can simply click a button to regenerate your CAM program. So various types of manufacturing capabilities. And how we have brought this to you, there are a couple of things we have done. One is Fusion 360 as a base has a lot of those capabilities that we talked about initially. So they come to you with the base itself. So the base of Fusion 360 platform has all those capabilities in manufacturing, but there are sort of advanced tools that come from a set of our advanced manufacturing solutions, such as Power Mill, Power Inspect, and so on. So some of the capabilities from these tools are also integrated in Fusion 360 and are available to you as something known as the manufacturing extension. So which allows you to do on-machine verification, inspection, toolpath optimization, tools, things that you can do to avoid automatic collision for 5-axis toolpaths. Also supporting metal additive manufacturing. And when I say manufacturing, it's not just slicing it up. It also calculates, factors out the time it takes, the heat it generates, the all the deformation that is likely to take place in that process, and compensating for that along the way, and also supporting advanced manufacturing methods such as rotary milling. So this manufacturing extension is something that is available as an extension to the base Fusion 360. So we have already mentioned access across devices, whether it's a browser or mobile, but also PC and Mac. Also, Fusion 360 comes with a library of open source free standard post processors to post G-code to nearly every machine. In addition, there are free training courses on Fusion 360 website and thousands on YouTube videos to ensure you can learn Fusion 360 effortlessly. We are also providing access to advanced capabilities and technologies through consumption services such as generative design or the manufacturing extension. So the way to access generative design and manufacturing extension is uh, you know to access them when you need by consuming a few cloud credits. So in Fusion 360, we have integrated the best of the tech that we have, and which is the industry leading tech that is available out there in the form of generative design, design optimization, high-end simulation with Nastran supporting processes for additive. And what we also plan to do is support areas of molding in the future. And of course, you saw that CNC is also integrated metrology inspection is already there. What may also be seen in the future is things that are to do with composites, fabrication, and the entire process of the advanced tools that Autodesk has is perhaps is the way ahead for Fusion 360 as an integrated solution with all these capabilities. Now, designing validating, and of course manufacturing. These are the capabilities. But in an environment where we are doing this, there are times when we need to share, we need to get feedback. We don't do things in a silo. We are doing it for someone. We are doing it with someone, and there are people who validate, approve of what we are doing. So there's a lot of supply chain collaboration that drives an organization. So just as an example here, we are talking of a company called BASF. So Fusion at BASF is driven by their global ambitions to digitize their production facilities. Fusion will support BASF's plant maintenance process and shop floor. Collaboration with external partners, example for spare parts, visualization of data for VR, AR through HoloLens with the content from Fusion 360. So what they have gained in as a result is increased efficiency, faster turnaround, better quality and availability of data during the plant maintenance schedule, greater transparency and of data on global scale, reduced local effort in operations and IT, and attraction of young professionals. This is a very new and a young platform with a very fresh look and feel, and the tools all within one platform, which definitely the young professionals of today find very interesting and easy to adopt. So it's definitely attracting more young professionals to work. Now, collaboration, sharing information happens in a certain way. So how does it really happen, and what are the elements of being able to share and manage data? So Fusion 360 allows for various ways in which you can share and collaborate. You can collaborate with specific team members, you can collaborate with specific external stakeholders, and you can collaborate as and when you want, without the fear of the collaborator with whom you are working not being able to access your data, because today Fusion 360 data is accessible on absolutely any device, any operating system. So it could be your Android phone, it could be your iPhone, or your tablet, or your mobile workstation, or a laptop where you are using a browser, and absolutely with no installation of any software, you can access data for the purpose of collaboration and share your feedback in a secure environment with capabilities such as version control, commenting and redlining, and with the way to export and download whenever required, and if you're allowed to, based on the rights and access given to a certain user. And not only that, one of the things where we struggle a lot is sharing, searching files. And Fusion 360's cloud-based search engine allows you to search and browse through the data with simple keywords and get to the exact right file that you're looking for, or right data that you're looking for. So there are many ways in which a Fusion environment can be built. There are ways in which you can be totally restricted and within the premises, rather within the close group of your internal stakeholders, and there could be a space where you're only sharing selective information with the external stakeholders such as customers, suppliers, and your design contractors, in definitely a secure way. So not everything for an external stakeholder is accessible to what is available to internal stakeholders. So workflows that allow you to for secure sharing of data with the right people, and not everyone gets to see everyone else's data as well. And this is all about anywhere, anytime, anywhere access. to the information your extended organization needs for quoting, procurement, supply management. So a lot of teams can leverage this information, being accessible anywhere and on any device. So a lot of possibilities with this way of working. Easy to share, easy to collaborate without having to worry about the platform, file format, and the device. And some of the reasons that I think you should definitely look at Fusion 360 and why I definitely think you need Fusion 360 today is that it is a total connected platform. So in Fusion 360, it's not just about the design and the data, it's about data and people. So in Fusion 360, when you are creating a project, you create a project for a set of people who will be working on a set of data and always be connected to that data, wherever they are and using whatever device. And not just about connectivity, which is definitely one of the I would say the topmost reasons why it should be there with you, but it has all the best tools put together in a single platform, right from electronic design to detailed and advanced mechanical design, mechanical simulation, and getting into manufacturing, both additive and subtractive, with the best tools that Autodesk has, all available inside Fusion 360. And there's a big community of people out there who are perhaps wanting to learn Fusion 360, are so fascinated by Fusion 360 that they're creating their own content, posting it onto social platforms. A very, very big community out there. So easy to get help, easy to learn. Absolutely no challenge in the content that is available. It's absolutely free for everyone who is starting to learn and adopt Fusion 360. And I believe Fusion 360 is one of the most transparent development that is happening in all the entire uh, design community. Because if you are already subscribed to the Fusion 360 newsletter, we have been sharing our future roadmap as well, where we are taking Fusion 360. It's absolutely public, and everyone today knows that today what is there in Fusion, what is going to come in the future, what is in the works, what is being prioritized, all this happening in view of the all the customers, and also based on the priorities being set by the customers themselves. Now, subscription access to Fusion 360. So just ignore the pricing out there. You can definitely look at the pricing on the Autodesk India website, also in INR. But the point being, the access to Fusion 360 as a platform is available at a certain cost, and you definitely get to access it at a per month or a per year basis for unlimited use. And there is also on-demand access or a flexible access method where you use advanced capabilities when required. So these advanced capabilities are something that you need once in a while, and your team or you yourself might need these extended capabilities not all the time. So we have built Fusion 360 as a platform where a lot of capabilities are available to you throughout the year, but there are some capabilities that you want to use only once in a design process and a very few times throughout the year. So depending on how you want to access Fusion and what are the things that you can do, you can access the base subscription with for which you can pay for a year, or on a on-year basis, and you can access some of these advanced capabilities in manufacturing or in generative design or simulation through on a on-demand basis also. So Fusion 360 is all about manufacturing peripheral partnerships. We are building Fusion 360 also as a platform where a lot of people are developing tools to plug into. So one the set of tools that you saw, everything from Autodesk, but there are other partners and partnerships that we are getting into, where We also where you will see a lot of our the partner community developing things that work on top of Fusion as an extension, will be also making it available to you as well. Connections to various machine tools, and definitely we have seen the rise in Fusion 360 monthly users. So both a very large user community from the students, who have almost all students today have access to Fusion 360, and a lot of students, or a lot of very large community of both startup and commercial users getting onto Fusion together. So by changing the question from what is to what if, Fusion 360 is revolutionizing how teams imagine, collaborate, and create, giving them the agility and connectivity to meet growing demands, the freedom to spend more time on innovating and iterating, and the ability to better your design, better your business, and shape a thriving future. So the future is here and it runs on Fusion 360. So this was my presentation for today, setting the context of where we are taking Fusion 360, what the platform is all about, and who are the people who can benefit from Fusion 360. And absolutely everyone in the design to manufacturing community. So with this, I'm going to end my presentation here, but there is one very last interesting slide that I'm going to show, which is about a promo that is going on for Fusion 360, which is going to end very soon. So please do make a note of it. I'm going to leave this slide on the screen for a while so that you can make a note of it. And as you do this, I would also request you to post your questions. I already see a couple of questions out there, which I'm going to try and answer to the best of my capabilities. So, uh, so using multi-body methods, can we extract forces of interacting parts and pins? I believe you're talking of reaction forces, and yes, we can do that. So for example, if you are driving a pin with a certain tolerance inside a dowel hole, you want to really figure out what are the reaction forces, and yes, we can find out the reaction forces if that is what the question is about. So can I provide the link to the Fusion 360 newsletter? This here it goes, and the next slide that is coming on screen has a barcode, and that allows you to not only access Fusion but also sign in for the newsletter as well. So please use this barcode to scan it with your phones if you can, and just go to the link and sign up for Fusion 360 and for the Fusion 360 newsletter also. So minimum hardware requirements, in fact, if you go and sign on this, click, scan this barcode, you will definitely find the information out there. But I can tell you generically, I can also just tell you generically that the hardware requirements uh, uh, are relatively leaner as compared to some of the systems, because a lot of the workflows are shared between the cloud and the desktop. So But having said that, to get the specifics, please scan the barcode, and that is where you will find all the necessary information, including the ones on the hardware. So can we now launch the next poll, as we are towards the end of the session? Avinash, requesting you to launch the poll. And as you continue to answer the polls, I will still answer the questions that are there on the screen. So is product data management a part of Autodesk? So yes, product data management is a part of Autodesk. In fact, Fusion 360 comes with a part of that data management solution in the form of a capability known as Fusion Team that allows you for version management and secure file sharing. And for complete desktop-based, on-premise-based secure data management and complete revision management, we have Autodesk Vault Professional. So if you are looking at the screen and the poll that is coming on, request you to please answer that. And request you to be very honest, did you relate to the workflows presented in the webinar today? Definitely will help us in curating the content for future webinars as well. So request you to all answer as best as possible. So if we see only perhaps half of you have answered, if request you to please kindly answer and let me know. Yeah, great. So great. Request you all to answer, please. It helps us, to be focused in continuing to do these webinars for you so that we know what you're looking for. So if you answer the questions, it will really help us to be very specific with the content that we present. And also there is the element of continuous improvement. I can also get feedback in terms of whether my presentation skills were up to the mark, or do you see any improvement needed there as well. So we can go on to the next poll, please. So do let us know if you want us to contact you. Even if you don't want us to contact you, that's absolutely fine. But do scan the link. Please go on the Fusion 360 website, read through the information out there, create your own login. You can absolutely try it out. Creating a login is as easy as creating a Gmail or a Facebook login or logging on to any social platform. It's as easy as that. So yes, for the offer to make sense, you really know what is the base to look at what is 50% of that, and request you to go to the Autodesk India website and go to the Fusion 360 page to really figure that out, and you will be pleasantly surprised. So definitely visit the Autodesk India page to look at the offer in more detail, and please do uh, look at it and consider subscribing to it as well. So if you are not familiar with the Autodesk India web page, this is it. It's autodesk.in, and just look out for the products, and if you just go out here, and if you go to products, you will find Fusion 360 out here. And when you go to subscribe, this is where you'll find a lot of information of what it is all about. And here you see the limited time offer, and here you will definitely see more information that is India centric, which is in INR, which is in Indian rupees. So please go on this page, and request you to have a feel of it. At least try it out. That will definitely give you a perspective of what I presented today. So with this, I think we would like to end the session for today. Really appreciate your time and patience, and hope to see you on one of my other webinars as well. So please do join me in the future. There will be list of, there's a calendar that is already published, and there are a few more webinars that are in line. So thank you so much. Have a very nice day. So Vinesh, we can close the session for today.
Yes, Sanjeev, thank you.
Thank you so much.